Hello everyone, I am Manohar from CSCB. I am presenting my tech talk for subject Math, Linear Algebra and Calculus. The topic I have selected for the tech talk is Ultrametricity of two infinite matrices. Now moving on to the contents. The contents content abstract, introduction, divergent sequence, lemma, theorem, proof, references. Moving on to the abstract. In this short note, it is proved the existence to infinite matrices that not only preserve convergence and limits of sequence, but also convert every member of some dense vector space consisting, except for zero, of divergent sequences into a convergent sequence. Introduction. If this method is carried out by an infinite matrix A, defined as Aij, where I, j greater or equal to 1, then the A transform of a sequence of scalars x is equal to xn, where n greater or equal to 1, is given by Ax is equal to Ax. Hence, A can be viewed as linear operator. A defined as dA gives rise to omega, where omega and dA denote, respectively, the vector space Kn of all scalar sequences and subspace of all sequences. X belongs to omega, for which Ax belongs to omega, that is, for which every series Axi, where I belongs to n, converges. Divergent sequences that become convergent. In order to establish our result, it is convenient to fix some notation and to recall a number of facts from functional analysis and set theory. For example, set 7 and set 9, and also from the modern theory of linear ability, see set 2 to 4. The set omega will be endowed with the topology product, that is, the one of the coordinate-wise convergence. Then omega becomes an F space, that is a completely metrizable topological vector space. It is separable because, for the instance, the sequences in C00 with entries in Q, which is rational, or Q plus IQ, which is complex, according to K is equal to R or C respectively, from a dense countable subset of omega. Here C00 denotes the family of sequences with finitely many non-zero entries. A standard application of Bayes category theorem shows that dimension of omega is equal to C, the cardinality of the continuum, a family A lambda, where lambda belongs to A, of finite subsets of n is almost disjoint. Example, set 5. Lemma. Suppose that X is a separable infinite dimensional F space and that A, B are subsets of X satisfying the following properties. If A is stronger than B, A intersection B is equal to null set, A union 0 contains some vector space whose dimension equals to dimension of X, which is equals to C, B union 0 contains some dense vector subspace of X. Lemma 2.1. Then there exists a dense C-dimensional vector space subspace of X contained except for 0 in A. We are now ready to state our theorem by subsequence where nk, where k greater or equal to 1, we mean a strictly increasing sequence n1 less than n2 less than or so on nk of natural numbers. Theorem. Assume that A is equal to Aij, where I, j greater or equal to 1 is an finite matrix over the scalar field K, satisfying the following properties. For every j belongs to n, the sequence Aij, I greater or equal to 1 converges. There is a subsequence nk where k greater or equal to 1, subset of n such that for each one of the subsequences mk where k greater or equal to 1, subset of nk where k greater or equal to 1, we have a sequence where A sigma imk where k greater or equal to 1 is summable for every I belongs to n. theorem 2.1. Then there exists a dense C-dimensional vector subspace of omega, all of whose non-zero members diverge, but their A transforms converge. Proof. Let A denote the family of all divergent sequences. X belong to omega such that AX is a well-defined convergence sequence. That is, A is equal to A minus 1 into C divided by C. Proof. For every sequence of X is equal to Xn, where K is greater or equal to 1 belongs to omega. We denote by sigma x its support, that is sigma x is equal to subset of n small n belongs to capital N given by xn not equal to 0. If we have finitely many sequences x1, x2, so on xp belongs to omega by C00 such that the family of the supports subset sigma x1 so on to sigma xp is almost disjoint, then such sequences are linearly independent. This shows linearly independence in the given proof. Proof 2.1. Pick an almost disjoint family NS where S belongs to A of finite subsets of N with coordinates of A is equals to C. Divide each set NS into two disjoint finite sets. Say NS is equal to N1S union N2S. Let N1 less than N2 less than N3 so on less than Nk be the sequence given by assumption of A. Consider the almost disjoint family Nk, where K belongs to Ns and S belongs to A. For each S belongs to A, we define the sequence US is equal to USM, where M greater or equal to 1 belongs to omega. Proof 2.2. Notice that every TS matrix satisfies conditions A and B1 of theorem 2.2. Indeed, each column tends to 0 and B1 is fulfilled with any subsequence Nk, a subset of N. Due to the absolute convergence of each series P infinite J is equal to 1, Aij where I belongs to N. Condition B2 is satisfied by, for instance, the TS matrix A0 defined in section 1. Take Nk is equal to K2. This would give 0 as the limit for all sequences of B2. So concluding the existence of TS matrices, converting a large amount of divergent series in convergent ones. Proof 2.3. Finally, one may wonder whether there are TS matrices converting every divergent sequence into a convergent one. This is far from being true. As a matter of fact, given a TS matrix, there is a sequence of x is equal to xn, which belongs to omega, with xn is equal to plus or minus 1 for all n belongs to n, where small n belongs to capital N, whose A transform and AX diverges. Acknowledgements. The first author has been supported by Plan Andalou de Investigación and de la Junta de Andalou and by MEC Grant. The second and third authors have been supported by MEC Grant MTM 2016 code VA5963P. The fourth author has been supported by the Grant MTM of the year 2015 with the code 65825P. References: Aaron L. Bernal Gonzalez, Spanish, D. Pellegrino, and J.B. Sioan Sepulveda. Name of the reference or the book published by these four authors is Linearity, which includes the search for linearity in mathematics, subjects, monographs, and research notes in mathematics topic. The publishers are The well-known publisher Chapman and Hall, CRC, Boca Raton. I think it's in Florida. It was published in the year 2016. A. Perimhoff, Lectures on Summability is the topic, and it was published in many places like Springer, Berlin, Heidelberg, New York, Tokyo in the year 1970. Lecture notes in mathematics. Thank you. We have come to the end of the presentation. Hope you liked it. Thank you so much for watching. This is Saishnu Manohar from CSCB presenting my tech talk on linear algebra and calculus. Thank you.